Okay, so they give me a function. And then they ask for the limit as x approaches a. So I use my limit flashcard. X is not approaching infinity, so I don't compare terms that add. Item 2 on the flashcard is to factor. So I want to factor this. So that's a difference of squares. So my new formula for f is going to look like this. Going to have, well, let's do a little scratch work first. So let's see, the top's going to become x subtract a multiplied by x plus a. The bottom is already x subtract a. So if I write them as separate factors, you want me to talk more about that. Okay, you need to understand the following and then make a flashcard if it's not a permanent memory already. When you see something like this would be a good example for the flashcard. What must you remember about this fraction as you are taking the test? Over out. Let's go with Tommy. This is equal to 1. 2 points for Tommy. Are there any exceptions to this equaling 1? Let's go, Kelly.
A.
If x has a value of a, points for Kelly. If x has a value of a, what is this going to equal? 8.
0.
0 divided by 0, which is undefined. Okay? You need to make sense of that flashcard and memorize it. This is equal to 1 for all values of x other than x equal a. At x equal a, this is undefined. We need to talk more about that. This happens all the time, all year long. So, cool. Let's see. So factored, but notice in this particular piecewise function, I am not supposed to be plugging x equal a into this formula. So I can declare this to equal 1 for all values of x that are applicable in this formula. So that means f of x is going to equal something really simple. X subtract a, whenever x is not a value of a, and then it's going to equal 0 otherwise. So when x has a value of a, the y-coordinate is 0. So I'm supposed to find the limit as x approaches a, which means I'm supposed to figure out when the x-coordinate is getting really close to a, what's happening to the y-coordinate. So I want to think about x, a being a little bit less and a little bit more. But in either case, oh, messed up here. This is plus, thank you. How many saw the mistake? 2 point. So either way, a added to a is going to be 2a. So as x gets close to a, the y-coordinate is close to becoming 2a. That makes this limit 2a. We want more discussion on that idea. There are questions on the test, absolutely, that have as part of the limit problem, letters, not just numbers. Like the idea is to see, they're trying to test and see if you can understand the idea of a limit, not copy it.
How did you get the 2a?
So talk with me, it'll make more sense.
Like, I get.
That's not what it is. Sorry, I'm going to ask you some questions. My bad. So, somebody answers, what is the purpose of this? What does this mean? Just waiting for a few more hands. What does this mean, Sarah? What is the purpose of this?
It's like to find the x and y coordinates.
Yeah, it's just to find the x and y coordinates. Mostly we use it for finding y. We just plug in the x, find the y. But you can do it backwards. 2 for Sarah. So you plug in an x, you find a y. That's what this is for. Limit just means plug in something that's close to a. So I'm going to plug in close to a. Well, do I use the top formula or do I use the bottom formula? And why? It's okay, 2 points. So why do I use the top? So look. This is perfect. This is exactly what you have to do to be prepared for an AP Calculus test. you have to keep asking yourself, did I know the reason why? And if you're doing problems and you can't think of the reason why, it's gonna get you on the test today. You're gonna get stuck. Valid reasons why. Some things I have simply told you, please memorize this fact. That's a valid reason for this class. But in other cases where I've said, no, you need to understand the reason, I'm telling you, you must understand it so they won't fool you on a test question. So, Sarah said, 2 points for Nathan again, another 2 points. Sarah said the purpose of this is to find the y-coordinates of the function. So we want to, when we're finding a limit, we want to say the x-coordinate is going to be close to a, what is the y-coordinate going to be? So am I supposed to use the top or the bottom, and why? How do you know? Your hands. Use the top, use the bottom, Brianna, and how do you know?
Use the top because you're not finding what it is exactly that is, you're finding it as it approaches it.
Perfect. Good point. So I'm looking for what happens when x is almost a. Not exactly a. So I put a value here that's almost a. Well, if you have, this sounds dumb, if you have almost an apple, and you add it to another apple, say out loud, what do you have? Almost 2 apples. So we have almost 2a.
Yeah, that makes sense.
Good work. Like I hate. Super L. All right. You made me laugh. Look, I try really hard to not be plagued by what is known as the curse of knowledge. So the curse of knowledge from a teaching standpoint is, if I start to understand this so well that I lose track of the fact that you are learning it for the first time, and I just lose the ability to honestly empathize with how you are learning, that's bad for me and for you. Okay, fair? So I'm trying my best after 12 years not to do that. To say, no, let's get the best of both worlds. I've done it for 12 years, therefore I have lots of experience that can help you, but I want to not lose track of the fact that things don't always make sense. But I can't tell all the time. That's why you have to speak up. When you don't know the why, you just say, I don't understand that. And then hopefully I can find a way to help it feel better for you. We need to talk more about this. Okay, cool. It says, does f of a exist? Somebody, what does it mean for f of a to exist? Like, what is f of a? What does that even mean? Savannah?
Thinking if you plug a in for the x coordinate, you get out a y.
Perfect. This symbol is a y-coordinate. And it's exactly what Savannah said, 2 points. It's the y-coordinate for this function f when the x-coordinate is a. So if you're making a table, you plug in precisely a, it is 100% correct to say the y-coordinate's f of a. Now, if you can find this to be some numeric value, that's better. This is just a symbolic representation of the y-coordinate. But this is the y-coordinate. Okay? I mean, knew that before she said it? Point. Somebody comment, does f of a exist, and how do you know? Just wait for a few more heads. So does f of a exist, and how do you know? Let's go, Luke. There's no Luke in the room. Shoot. His brother. Somebody's brother. Thinking of a totally different person. Person I will pay probably doesn't know I was thinking of this other person. Sorry, Colby. Trying to remind me of some Luke, so. You guys wait till you have 2,500 names in your head and see what happens. Holy talkie. Does f of a exist?
Yes.
How do you know?
It says when x equals a, f of x when x equals a, it is 0.
Yeah, f of a is 0. That definitely exists. go along with this together. Questions? Anyone want to talk about that? I really should stop saying the word question, because when I was a student, I don't think I ever had a question. I would just sit there and go, I don't get it. Is that fair? Like the teacher goes, any questions? Like, not a one. I don't understand what the heck you were even talking about. So I try my very best to just go patiently and just speak up if something doesn't make sense. They want to talk about this. Okay, cool. If this continuous at x equal a, that prompts my memory to have a flashcard. I would say there are more than two maybe, I don't know. I'm thinking of two key things I must remember about continuity. Whether this is one flashcard or two is your choice, I don't know. You need to understand first though, before you flashcard. So don't write anything until we have talked about it, you understand it, and then you flashcard it. So, let's see. I have to remember that a continuous function can be drawn without lifting my pen. That's an easy definition, but it helps. Continuous function can be drawn without lifting my pen. That's continuous. So I've seen that be a clue that will help me answer a question many times. Continuous means I can draw the function without lifting my pen. But also I've seen questions where I must identify one of three types of discontinuities. Let's see. Jump, removable, vertical asymptote. So I have to have that memorized. I've seen questions where I have to know how to identify whether the discontinuity is a jump, removable, or vertical asymptote. So I want to get a little reminder up here. Give me a second. So way back on an earlier homework, I do not remember which color, you had this in your notes. You will be tested on this on Thursday. So a jump occurs, and you should test them in this order. A jump occurs if the left and right limits are different. End of story. That's what causes the jump. Removable occurs, so if there's not a jump, then you go on to see if there's a removable. Also remember, removables only occur in piecewise. So if there's no jump, then we check to see if we now know that the left and right limits are the same because there wasn't a jump. We're now looking to see if the limit value is different than the function's value. If the limit value is different than the function value, then you have a removable. Common way for a removable to occur is in a piecewise function. But another common way is you plug in an x-coordinate of, I don't know, 8, and then, so it's not x approaching 8, it would be actually x equaling 8. So if I plug in x equal 8 into some function, this is for finding a removable discontinuity, and the y value becomes 0 divided by 0, that's a removable. This type of function behavior will cause the left and right limits to be the same, but those left and right limits will be different than the function's value. That's a removable discontinuity. If these two are the same, then the function is continuous, and you have to have the definition of continuity memorized. This definition expanded would look like this. The left limit must equal the value of the function at a, and that must equal the right limit at a. talk more about any of that. That's kind of the whole download on what you have to be understanding and remembering with regard to continuity. Jane, please.
Is there jumps with piecewise?
So jumps only occur in piecewise.
Okay, and then
And-
removable can?
Right, so removable, so jump will only occur in piecewise and only at the transitions. Transition is, what x coordinates where we change from one formula to another. Jane had it right, 2 points for her. Removables can occur in piecewise, but they can also occur if you have a formula where if you plug in some x value, you end up with y being 0 over 0. That also can be a removable. So 2 different ways to get a removable discontinuity. You want to talk more about the, please, Tyler.
How would you find a vertical asymptote?
Thank you, forgot that one. So vertical asymptote doesn't really follow this per se, it's a separate kind of thought. Vertical asymptote occurs if you plug in an x value, whatever, just an example, and the y value becomes some number divided by 0. That's a vertical asymptote. That's a pretty funky 5 there. I made that. But, 2 points for Ty. We want to talk more about the cool. Copy this over real quick. So anyway, back to 10. They want to know if f is continuous at x equal a. They don't have a graph to look at. They're not asking me about discontinuities. So the thought that comes to my mind is the definition. I'm checking to see if the limit, as x approaches a, left or right, which I've already found, that value is equal to 2a. The value of the function precisely at a is 0. Hey, there is a removable discontinuity at x equal a. So f is not continuous due to the removable discontinuity. You want me to talk more about this one? Okay, oh, yeah, please. Sure.
But I'm just confused
Let me say something back to you, and if this doesn't clear it up, keep talking. I think what's causing the confusion in your brain is a misunderstanding as to what this means. So this is just a formula for finding all the y coordinates. With that. So if I think of this problem as just, hey, I've got a bunch of x's, and I need to find the y values. Well, there are lots of different x's I can plug in. This formula is telling me that if I plug in negative 100, the formula that I use is going to be this. Because the x I'm plugging in isn't a, so I just use, and remember this factored and divided was just x plus a. So I just have, negative 100 plus a. That would be my y coordinate. You okay with that? If I plug in negative 10, that value is still not x equal a. So my y value would be this. If I plug in 0, that's still not x equal a. So I get this. If I plug in exactly a, I don't get to use this anymore. So now I just get 0. If I plug in 1, I'm back to using the formula. Plug in 10, I'm back to using the formula. So basically, this is just saying that for finding all the y coordinates, I'm supposed to use this formula, other than this one y coordinate. So that has nothing to do with figuring out whether the function is continuous or not. To figure out whether the function is continuous, I just have to check the definition, which is when I got really close to A on either side, what y coordinate did I find? Close to A, like slightly less, I'm getting a y coordinate that's really close to 2A. Slightly more, I'm getting a y coordinate that is close to 2A. But right at A, I'm getting a y coordinate of 0. I don't know if I'm helping or not. Point. Anybody else? Cool. Stop this.